ND tutorial welcomes you to our today's lesson on balancing chemical equations. You have been given the following expression: carbon monoxide combining with oxygen to give us carbon dioxide. So the first thing you have to do is count the atoms of each element. We call this our reactant and we call this our product. It's good to understand this. Now, how many carbon can you see on this reactant side? The first thing you have to do, remember, you have to count the number of atoms of each element available. So, how many carbon can you see here? 1. How about oxygen? We have 1 here and 2 here. That combines to give us a total of 3 oxygen on the reactant side. Coming to the product side, how many carbon can you see? I have only 1 carbon atom as well. How about oxygen? I have 2. So you can see that the equation is not balanced. Even though carbon is balanced, for the fact that oxygen is not balanced, it means that the equation is not a balanced equation. So we need to do something. The second thing you have to do is balance this equation by adjusting coefficient. Please, never you change this subscript. This 2 here is known as the subscript. This is a subscript. This one has 1 as a subscript. Don't add or introduce another number. It is the same throughout the reaction. So never you change that. You can only balance a given chemical equation by introducing coefficients. Now, what can we do? We need to carefully look at the expression and understand the most complex molecule. We have oxygen occurring as a diatomic element here, which is O2. We have carbon monoxide and we have carbon dioxide. This expression and this one, they are more complex than this. So it is better we start balancing from that. Please, it's not a necessity, but just to make it faster and easier, always try to balance from the most complex molecule or compound. So what can I do here? If I introduce 2 now, this 2 is serving as a coefficient, is multiplying both carbon and oxygen. Just like in mathematics, if you have 2 brackets, x and y, it means that these 2 is multiplying what? X and as well as y. Take note of that. Therefore, this expression will change automatically because we have introduced 2. Therefore, how many carbon do we have on this reactant side now? It's no longer 1 but 2. We have to also ensure that the number of carbon atoms on the product side balances with that on the right-hand side. We have to then introduce 2 here also. This is no longer 1, it's now 2. Sorry, it's now 2. For oxygen, what can you see? Remember that this 2 is multiplying the oxygen. So we have 2 oxygen here and 2 oxygen here. That gives us a total of what? 4 oxygen atoms on the reactant side. Similarly, on the product side, these 2 that is serving as a coefficient is multiplying both the carbon atom and the oxygen atom. And already from the expression given to us, the oxygen atom already has 2 here. So these 2 will multiply this coefficient, which is 2, to give us 4 now. So when you look at this and you compare both sides of the equation, you notice that carbon is now 2 here and is now 2 here. Oxygen is 4 here and is 4 here. Therefore, the equation is balanced. You can tick it off. So this obeys the law of conservation of mass. The number of atoms on the reactant side must be equal to the number of atoms on the product side, because atom can neither be created nor destroyed. So it's always conserved. You have to understand that. So this is how you balance a given chemical equation. So let us take a look at another example. You have ethyne combining with oxygen to give us carbon monoxide and water. The same process, the same procedure applies here. So how many carbon can you see on the reactant side? We have 2. How about hydrogen? We have 2. How about oxygen? We have 2. if you move over to the product side, how many carbon can you see? I have only one carbon atom here. How about hydrogen? I have 2 here. Then my oxygen, look at it, I have 2 here and 1 here. So that gives me oxygen to be 3. The expression is not balanced. Only hydrogen seems to be balanced. Carbon is not balanced. Oxygen is not balanced. And we cannot go on. We have to obey the law, the conservation of mass. So what do we need to do? Remember, balance this by altering only the coefficients. And start always from the most complex atom. So I will leave out my oxygen because it's not complex. I will leave out water for now. It's not complex. Let me start with this. What can I do here? If I should introduce a coefficient of 2 here, what do you think? It means that my carbon is no longer 2 here. It becomes 4 because I will now say 2 times 2. That gives me 4. So I have to also introduce 4 here to balance this carbon. This is no longer 1, is now 4. So my carbon is balanced. Let us see. Remember that this 2 is also multiplying this hydrogen. So 2 times 2 for hydrogen is also 4 here. Okay. So on the reactant side, I have 4 hydrogen atoms. On the product side, I still have 2 hydrogen atoms. So I need to alter it. What can I do? If I put 2 here now, that gives me 2 times 2. Hydrogen is also 4 now here. It's balanced. Then let us look at our oxygen. Here, how many oxygen can you see? 2 times 1. We have 2 oxygen here. How many can you see here? 4 times 2, which is now 8. So 8 plus 2 is 10. Our oxygen is now 10 on the product side. But on the reactant side, it is still 2. So we need to do something. How can I change this 2 to 10? If I introduce a coefficient of 5 here, I think it will balance up the equation. So let us see. For carbon, 2 times 2, 4. 4 times 1, 4. Hydrogen, 2 times 2, 4. 2 times 2, 4. For oxygen now, 5 times 2 is 10. And 2 times 4 is 8 plus 2 times 1, which is 10. So the equation is balanced. You can as well tick it off. In this example, ammonium carbonate decomposes to give us ammonia, carbon dioxide, and water. So the same method is applicable here. It's always the same in every given chemical equation. What atoms do we have here? We have nitrogen, hydrogen, carbon, and oxygen on the reactant side. On the product side, we must have similar atoms. Remember, you need to conserve the mass, the atom. So, nitrogen, hydrogen, carbon, and oxygen. By atom, how many nitrogen do you have? Now, it's interesting. These 2 here, this subscript here is multiplying everything in this bracket. Take note of that, please. This subscript here multiplies everything here in this bracket. So it becomes 2 times nitrogen here, which is 2 nitrogen atoms. 2 times 4 for hydrogen, which is now what? 8 hydrogen atoms. Carbon, of course, is 1. 1 carbon atom. Oxygen is 3. On the product side, how many nitrogen can you see? 1. How about hydrogen? 3. Carbon, how many can you see? No, hydrogen is not correct. Hydrogen is not correct. It should be 5. We have 3 here plus 2 here, so we have 5. Then carbon, how many can you see? Of course, is 1. How about hydrogen? Our oxygen, we have 2 here and 1 here. So we have 3 oxygen atoms. So oxygen is balanced, carbon is balanced, nitrogen is not balanced, hydrogen is not balanced. So what do? Remember, do not touch the subscripts. Don't touch this 3, don't touch these 2. Never touch these 3 here, never touch these 2 here, never touch these 2 here. You can only balance it by introducing coefficient. And what is the most complex molecule? This is the most complex molecule there. So this is the most complex. So let us look at it and see what we can alter. So nitrogen is 2. Look at this. Remember that nitrogen is 2 from here. So if nitrogen is 2 here, that means I can actually introduce 2 here. So if I introduce 2 here, it's no longer 1 for nitrogen on the product. It becomes 2. How about hydrogen also? Hydrogen then becomes how many? 2 times 3 will give us 6 hydrogen here. Okay, beautiful. Our carbon, of course, is still balanced. So we have 6 hydrogen here, and there's another 2 hydrogen here. That gives us a total of 8 hydrogen atoms. I think the equation is balanced. I have 2 nitrogen, 8 hydrogen, 8 hydrogen, 1 carbon, 1 carbon, 3 oxygen, 3 oxygen. That's just how to balance chemical equation. So remember the first step. List out the atoms of each element and then the numbers of this atom available on the reactant side and on the product side. Having done that, try to balance the expression or the equation by adjusting the coefficients. Do not change, alter, touch the subscripts. This is a subscript. You don't touch them. And the next thing is not compulsory, it's not mandatory, it's not necessary, but it saves time and it makes it easier. Try to balance your equation starting from the most complex compound or molecule. I believe it's understood. If you have any question, you can reach out to me directly. Thank you and stay blessed.